Welcome back to Wickerson Studios. My name is Michael Wickerson, and I am on a complete conceptual high with what's going on here. And I'm just going to go to Turntable and show you that I've made some pretty beautiful forms. And even though it's very simple, Grasshopper in the end, this is all driven by machine learning and logistic regression for my second sample of making geometries. And I'm forcing myself into figuring out an awful lot more about scripting. And even though this is very cumbersome, somebody who really scripts in Py and away from Grasshopper might think, what kind of fool is trying to mix node scripting with Python scripting? But I'm trying to build these base nodes to know certain things. So this is another one-liner logistic regression 006. And let's just take a look at it. Let's jump in here and take a look at this form. It's made very nice, pretty nicely, as you can see. As it goes through and it changes, you can see the distance between these lines. So how am I achieving these really fluid lofts between these points, and how many points are there for articulating? And if you did these in ribs or flat pieces, you'd have a gorgeous piece of sculpture if you kept this dead simple. So I'm going to go in there and have a little fun with it. I'm going to show you what's going on here. Basically, that's the form, so we can leave that alone for now. We'll come back into it in a minute. Keep in mind that this is a series that's much larger. If I panned out, you'd see that I've been working on, this is the first that dealt with logical linear regression. I'm using the remote ghPython node. These files are available through my GitHub, and that's through Patreon membership. Logistic regression, I have a lot of information about it, talking about what exactly it is a categorical S-shaped function using the sigmoid function. There's a sample that I use here that's just basic right out of the book, but what I did was I used it and I really started to tear it up and see what I could do with my own script. So let's jump over here and see what the script actually entails. And a lot of things in my scripts are kind of cumbersome. I keep everything in there. I keep a sample of linear regression because I want to know how to pull from my libraries that I've actually imported into the module through the remote node. I have a few examples. I want to put together an array, but I want to make that parametric. So I'm going to bring in low, medium, high, and high. And I've got a setting that can go from a range of 1 to 10 on the first one, and that drives the geometry. But basically, let's think of it as, let's set 10 for the low, and that means no. And that's just a puzzle I have associated with it, which was tied to this cancer cigarette. If you smoke enough cigarettes, then will you get cancer, yes or no? So there is a little puzzle tucked in here, and I call this the puzzle sample. So if you play with these numbers and play with these numbers, you'll end up outputting no, yes, yes, or no, no, yes, or no, 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 or yes, yes, yes. Just to play with those three samples to give you a feeling that, there's a purpose to this beyond geometry. But it really is a one-liner logistic function, which is outstanding. I pull it in a logistic regression. I fit it to its parameters, and I shape it to a single. It finds its own. Actually, you don't even need the net length in here. This is totally useless now because it's smart enough to find its own, reshape its own, which is pretty nice to use -1. It's pretty amazing when your script's smarter than you. Then basically I'm able to output, you'll see all of these values. And what I end up outputting is not everything. I'm actually outputting just a few bits of data. And so I chose this kind of yes, no as a 1, 0 to change the data, which would drive it completely. If I went from here to here, you'll see the data does change. It takes a little bit of run, 4 seconds to run. That's going to totally transform the geometry when I do something like that. Because once I get this data that is as many values as I want, I think I have 100 values here, which is driving it, which is giving total detail. And it's slowing my script down to 4 seconds. But basically, I want to drive data by these functions and these psychic machine learning functions. So actually, I'm going to jump back and forth on this one and show you what's happening. And then I've actually put out the printed model to say what's the outcome of that puzzle. But then I've had the list, and here's where it gets in the Grasshopper again. I have to pop that off because all I want to do is deal with these. But because I'm dealing with NumPy and I'm dealing with lists, I've got to get in here and do some concatenation. So I pull out the parentheses, replace them with nothing, and I'm able to have the data, which is then taken into floats, and those they become something different, and they're really nice probabilities all the way through to high and low probabilities. And then those are driving as a list item the range of very simple circles that go through a motion and move after it's divided, and it's lifted up, and I draw a line between and I loft those forms. So in the end, I'm in with, if I close my file, hit OK, let it run, and then shrink this down, you can see what I have here. So I just popped on another beautiful form, and you can see how that one just echoes against the other one. So if I took that bake in, what a nice shift. It just shifts the probabilities perfectly. And so now I'm able to go in there and bake another one, which will be fantastic. Let's bake it to level 5, hit yes, okay, and there you go. You've got 1 and 2 that fold directly into one another and become this very interesting form. This one and this one. I think I'll take this one and pop it on visibility gone, and we can always shift it back. And that's just a little bit of just selecting the data from one side to the next. So if I pop back here, it's going to take 4 seconds to run. Can't run it as a Boolean. I have to run it as an integer, and I'm getting better at that. But I like that. Really beautiful form. Nice little grasshopper techniques that I used to play with over here. You can also drive that data by changing the radius. You can change the height. It will take some time to do. But let's get in there. Oh no, it doesn't take long because it's after the running. Once the function's done, now you can drive this geometry and change this however you want. Really nice. So I'm going to go in here and just grab ghosted. So we have this form that was there initially. I will. Oh, I knew there was a bunch of stuff in there. I'm gonna let me swap and grab all these other geometries from an exercise before, go back in, and then we'll swap that back out, and there's the one. Okay, so now what's nice is it takes a while to drive all this data, and this is the script that slows down to 3.9 seconds because it's checking everything. It's running a probability, it's running a sigmoid function, but after that you can really come in and start playing with your geometries just off of these ranges of what you have, and got a pretty nice form. And then if you wanted to grab the other ones, say that one was worth baking, bake. We'll just say yes, join. It's not really necessary. My head's in the way, which is always a pain. So there's that first one, and then we can come in, we can grab that again, or we could do that swap back over here. Now you could also drive the data differently by playing with these numbers. So I think what I'm going to do is have an influence on the curve here, bring this one down for less in the range in the samples. We'll pull that one down to 50. See what that ends up looking like. It's going to take 4 seconds, right? So there you go. You've got another form that comes out totally transformed. It doesn't wrap all the way around, so you've influenced that. Let's flop that around the other way, which will take another few seconds. There's the other one, and not bad. Not bad to think about what's actually happening. Interesting, it plays off of that. And then if I want to drive this data down, let's bring this down to 1. Another 4 seconds run. I think 0 might be too low, but it's going to influence the curve. Really play off of that, and you're totally getting lost in the data now. I didn't mean to do that, but I did. Let's see if it pops down lower to 11, which is the lowest number. So you are playing with those. Let's take a bake and see what that one actually looks like. It's got less, so it's going to be interesting. I mean, you're driving your data by these custom nodes. We took a look what we have here. You can see there's a lot less definition. You could have wider slats instead of all these range of 100. You've got 50 in here to play off of the slats. So, just trying to get to some interesting geometries, simple grasshopper techniques over here. You can still play with those and shift those and change them on scale. I'll take that one, get rid of that, and pretty beautiful things that you can make. If you end up bringing these two together and do a Boolean union, then put it back in the Rhino, you might have a very interesting ring to start with. So once again, I'm back to rings, sculptures, architecture. Kind of rambling on, but dreadfully excited about where this is going. I'm going to grab this and just put a file, save, and you can see what's happening. It's pretty organized. I'll be taking a new, the next one actually is going to be, and I'm very excited to say, I believe K means clustering in one line, so that'll be number 3. So we'll do linear regression, logistic regression, the sigmoid function. I really can't explain this all in a 5-10 minute video. It's something that's really, I'm taking the time to translate and playfully try and make these examples. Hopefully when I have these 10 done, we're getting in then farther and farther into the advance, and we'll start getting into more complex algorithms. Thanks again for watching and tolerating my rambling as I spontaneously dig into this stuff farther and farther and farther.